Standard for statistical data dissemination. Now, let me begin with a brief history of digital data dissemination. Now, the first stage of digital dissemination is you have a browser, you have an internet connection, and you end up in a place like this, right? Now, this table has been designed for humans. And in fact, it has been designed for naked humans, because you don't have to have any tools to access this information. You only need a pair of eyes. Now, the second stage of digital data dissemination is this kind of, this information is accessed and read by humans. The second stage is related to this kind of functionality where you can export, where you can download a file. Now here, this is still for humans. But for humans with machines, with tools. Now, the information is actually accessed by humans because someone has to pick a format, but finally is read by machines. You download the file and you process it with, for example, some statistical software. Okay. Of course, this model doesn't scale up, and we need to get rid of humans altogether and try to find a solution for machines, or at least put humans in the background, right? And the third stage is this stage. It's a stage where we open our data infrastructures, and this is a stage where everything is for machines. The information is accessed and read by machines. And that means that somehow we have separated our data interface from our user interface. Our website is just our user interface. That's for humans. But in this stage, what we have done is open our data through APIs to the rest of the world. And this helps us to face the challenge of the multi-channel device dissemination, because we have made this kind of separation. Now, I think that's what Matt McAllister for The Guardian was trying to say with this sentence. How I stopped to worrying about my website and learn to love the whole internet. We should begin to love the whole internet instead of focusing only on our website. And this is not only a technical need, this is a survival strategy, actually. Because if our information is not reused, we are useless. We operate in the reference market. We need our information to be reused as much as possible. And we are not alone in this market. Take, for example, the New York Times. The New York Times, of course, is a newspaper. But it's also a reference company. They want to keep trying telling us what events are news or what books are bestsellers. And we have done, what they have done is open up their data. They have built a developer network. They have APIs. Or the BBC, it's the same thing. Use our stuff to build your stuff through APIs. Or The Guardian, build applications with The Guardian. These companies are loving the whole internet. They are not only about their website. So my presentation is not actually about connecting these two dots, which are big statistical organizations with that they exchange information, and they do that in a shared environment. They have a shared culture. They meet regularly in events like this one. But about this kind of relationship. It's about dissemination to someone outside our circle. Now, this guy outside our circle is someone that is unknown. And this is just the same thing that happens when we build websites. This is just like the World Wide Web. We build a website, we try to have as many visitors as we can, but we don't know actually who is visiting our website. They don't have to contact us to visit our website. And here's the same thing. And the way to keep those visitors coming and coming is to be as much user-friendly as possible. And here we have exactly the same problem. Even though we are trying to prepare our data to be accessed by machines, these machines were built by humans. So we try to be as friendly as possible to developers. And we need to take into account usability and accessibility issues and apply the usual rules of thumb of those fields. Now, let me put you an example of a very successful platform. And this is Twitter, right? Anil Dash has tried to summarize Twitter API success in this sentence, and I think it touches all the important components here. He writes, these APIs are simple enough, first idea, this is the KISS principle, keep it simple. For weekend hackers, this is the idea of accessibility, of developing for also the weakest link, not only for the smartest guys in the world, but even for weekend hackers. To build interesting projects on, of course, you need to provide a useful service. And easy to implement even on mobile devices, which is about getting closer to the end users. Our end users are on mobile devices. We need APIs and standards that are suitable for mobile devices. And in almost any programming languages. We could say that programming languages are to APIs what browsers are to websites. When we build a website, we test it on the main browsers. Now, here's the same thing. Now, we could try to test the simplicity of a Twitter, of an API and of a standard by looking at the documentation, right? Now, Twitter actually has two APIs, and all those APIs, which are very powerful, are about 200 pages, printed pages actually, right? Now, that's about the length of Hamlet by William Shakespeare. Of course, you don't have to read all those pages because the documentation is very granular. There's a web page for every resource. So actually, reading about 10% of the documentation, you are a master of that API. Now, you could say that the Twitter APIs satisfy the 15-minute rule. And this is a rule that states that you should be able to get from 0 to hello world in 15 minutes. Now, let's compare this with SDMX. And this is the documentation of SDMX, right? Now, to begin with, we don't have that kind of granularity. We have a bunch of PDFs. First PDF, then we have another PDF, which is longer. Suddenly, we have this zip file with 8 Microsoft Word files, which suddenly we have all this. Then we have a sample section. Well, we don't count them. Another PDF, and another one, and another one, and another one. Now, total 1,400 pages. Now, of course, this is it's longer actually than the complete works of William Shakespeare. Now, this is a very high barrier to entry to most developers. So, maybe SDMX is okay for this kind of exchange between a national statistical agency and international organization, but I don't think it's okay for disseminating data for external third-party developers who are trying to develop applications in many fields, not only in statistics. SDMX is very flexible, but of course is very complex too. One route would be to simplify SDMX. I don't think this is an easy task. It's very complex to go from a complex system to a simple one, if you haven't built first a simple one. That's the Gall's law, right? Now, if we want to build standards who are user-friendly to developers, we should ask this question. What's common practice in the API space? Because most developers will know that, the common practice. So what I have done is I have stolen some slides from John Musser from Programmable Web, where he has done some stats about their API directory. This is a directory with 5,000 APIs, so it's a good sample. Now, the first conclusion is that REST wins over SOAP. Well, that's not very surprising, right? Fortunately, SDMX has a RESTful interface now. Now, the second conclusion is that JSON, the JSON format, is rising. 55% of all new APIs support the JSON format. And more importantly, 20% of all new APIs only support JSON, which means that XML is going down. And there are good reasons for this. Now, let's take, for example, this SDMX markup language fragment. Let me amplify it here for you. This is half the fragment in the right. We could translate it into JSON like this. Now, this is less than half the length of the XML expression, right? This will be this. Right? The first problem is this is only a way to do that. We could express it like this, or we could express it like this. Someone has to tell us how to express it, because there are many ways to do that. Now, of course, being less verbose, being a lightweight format is very important in the mobile device market, because we have to save as many bytes as possible, because mobile devices are slower than desktop computers and the network is also slower. JSON also is very natural to programmers and to programs. In fact, is faster to process than an XML document, right? And it's very natural to programmers because it's a data format, and it has all that data structures that all the programming languages has. And it's very natural to JavaScript programmers because JSON needs JavaScript. Now, JavaScript is not anymore this programming language for kids. JavaScript is a very important programming language because the browser is not anymore only a document viewer. It's an application platform, and that application platform has JavaScript as its programming language. And the browser is the only element in common in all the mobile devices. Right? So it's the way to try to develop applications for all those devices. So it helps us solve the problem of the fragmentation of those devices thanks to HTML and the JavaScript APIs, which brings into the formula more power, right? So one solution could be to try to express SDNX ML into JSON. Now, if we do that, if we try to build JSON from XML, usually what we get is XML-ish JSON, or worse, we get JSONify XML. And here you have an example from Mexico. Thank you, Abel, for providing this example. This is a real example. And this is not Mexico's fault. This is SDNX's fault. Mexico has noticed the necessity to provide SDNX in JSON. And they have done that. They have done an automatic conversion. Here, what you see is a lot of elements that are repeated. It's verbose still. You only have strings. You have values here that are strings instead numbers. You have namespaces. You have the differentiation, the metaphysical differentiation between elements and attributes. That's XML. That's not JSON. We need a natural whole JSON expression. We need genuine JSON. And this should be done from the information model probably, but not from XML. Now, another issue, I said earlier that we must save as many bytes as possible when we work in the mobile device market. And that's a very common situation. You have an API, a developer needs the price of an apple, but the API is not about prices, it's about apples. So the reply, the response of that API, the only way a developer can get information about the price of an apple is asking about apples and get all the information that API has about apples, the nutrition value, like allergies, recipes, price, whatever. Now, we need APIs that are more flexible, that should be able to have a partial response. This is very important in the mobile device market. Now, SDNX has something of that. It has this parameter, detail, where you can choose between full, data only, series keys only, no data, only 4 situations. Now, this is not flexible enough. In fact, it's less flexible than the model that Amazon has been applying since 2002, which is a response model, the response group model, where you can include some groups of information in your response, like information about images or about reviews, and you can combine as well the way you want. Now, we are beginning to see more flexible models. Facebook, for example, you can go to element by element. You can choose which elements can be included. Or here you have the same model. Or LinkedIn has the same thing. And Google has bring this to the max. I mean, you can do this sort of thing, include ID and type inside scope, but you can do very complicated things. That's really getting a very customized response. That is just moving bytes that are necessary. Now, so let me summarize. We need a standard that is simple, flexible, lightweight, developer-centric, mobile-friendly, REST-ish, and supports the JSON format, right? Now, what about the semantic web? Now, unfortunately, the semantic web doesn't mix very well with these features, like this one. So, if you want, and here you have the proof. Only 1% of all APIs offer RDF support. Developers don't know about RDF. They are not used to work with RDF. So if we want to use this statistical data cube vocabulary with RDF, which is okay, we should be, we do it for political reasons. We do it because we want to contribute to the semantic web success, not because we are going to get any success of, any return of investment in the short term. And actually, we're going to have to support another format for dissemination, because this is not going to be very widely used. Now, the semantic web is aware of that, and they are trying to solve that. They are trying to express linked data in JSON. They have this linked data API and formats to simplify use of linked data by web developers. Now, we have three possible routes, no? Simplify and JSONify SDMX. We can reuse or adapt an existing data format, or we could create a new simple standard for stats. Yes, yet another standard. Now, I'm afraid I have committed that sin, and I'm promoting a new standard, which is called the JSON stat standard, which has these features. It's a JSON format, it's lightweight, it's simple, it tries to be developer-centric, it's flexible, and it comes with a JavaScript library, which is somehow the sandbox where we try to demonstrate that this is easy to work with. And it has this, it looks like this. It's actually always, it's all the data is inside an array, doesn't matter. I'm reading there, stop. Can I, 10 seconds? It's actually an array. It doesn't matter if it's a time series, a table, just a single value, always an array. And you access this array with this information. And it's optimized to get information, individual values from that array like this. Everyone is welcome to the JSON stat community. Otherwise, it's going to be a very bad standard. And I don't have more time, so I'll leave it here. Thank you.
Thank you very much. It's very, very interesting. You have posed some very interesting questions coming out of that wish list. We've probably got time for a couple of quick questions before we move on to the next presentation. Does anybody have any questions for Xavier? Okay, we'll be saving their energy for the workshops. Okay, Eric.
Could you tell us about this community, JSON Stat, in terms of who is participating today and what is the work plan of this community somehow?
We don't even have a roadmap. What we have, it's about, we have 18 members in the community. Only 3 active members, actually. One is Vincenzo. We have Alberto from the International Monetary Fund, and myself. We have a Google Groups where we discuss this kind of thing. And I have been the developer of that JavaScript toolkit. And I'm not a very good JavaScript developer, which is a proof of concept. I mean, if I can do that, anyone could. And everyone is welcome. I think we have someone from the OECD, Jack of Fix, as a member.
And you don't see any other initiative currently ongoing that could fit the needs, which leads you to say we need somehow yet another standard?
I'm not aware of any standard with the in JSON for expressing multidimensional information. No, I'm not aware. If someone is aware, please let me know.
Okay, thank you very much. I was going to call you Jason there.